We are now truly in a world where every system, every workload, every service inside of your architecture is doing some sort of action on behalf of a user. And in these cases, you need to make sure these services are behaving as they should and make sure they are authorized correctly inside of it. So every bot, every workflow, every AI agent, every LLM call that's going on, every function call coming out of your systems can now be issued an identity. And these identities are more and more commonly non-human. They may be acting on behalf of a user, they may be acting on behalf of an ultimate human behind the scenes, but issuing those individual identities to these services and workflows and background jobs enables you to actually start rationalizing from a system perspective and a security perspective exactly what's going on inside of your application architecture and what systems are calling each other inside of their request chain. The difficulty when it comes to managing these identities, firstly, they're numerous. There's going to be orders of magnitude more non-human identities than human identities floating around your system. Is how do you actually properly authorize them? The first step of actually understanding a security system is knowing who is calling what. So issuing those identities using a framework like Spiffy to give each workload, each service, give each agent its own identity enables you to start rationalizing what's going on. Now, what you don't want to be doing is having to implement all that custom authorization logic inside of each service. You want to be able to take the identity, verify it's an actual identity using key sets and those kind of mechanisms, and then actually start making authorization decisions around what is going on and what is happening inside of the application through that identity. Now, what you don't want to do is have to have all that logic hard-coded. So taking an externalized authorization approach really helps you sanely tackle this problem that's going to keep hitting us as our systems scale up and as more agents start evolving and working inside of an architecture. So how do you go about actually implementing authorization for non-human identities? The first off really is that, making sure you give every service, give every agent, give every cool part of your call chain an identity. As I mentioned, things like Spiffy are great frameworks to do this, but equally you can issue service accounts, you can issue client credentials to each of your applications, but ultimately there needs to be some sort of reference, some sort of identity attached with every call that's going on. Now, that identity could be just the service itself, or it could actually be issued on behalf of the person upstream making the individual request. But ultimately, you have that identity in the request chain. Next up is actually using that identity to make informed authorization decisions. So when your application gets called, making sure you then having a policy decision point, taking that identity, evaluate policy against that identity using aspects of it. So, which cluster, which environment, which namespace is this identity coming from, but also even inside of that identity, looking at the parent identity that may have issued it. If you want to do kind of request chain hierarchies, you can start making informed decisions that this identity is working on behalf of an actual user, as your human, and use that within the authorization logic. So in the case of Cerbos, you would write a policy as you would normally, starting to inspect attributes about that identity and the further nested information about it. Then on the application side of things, when that request comes in, they're trying to hit some endpoint, it's trying to do some sort of method call. Before you go and allow that request to come through, you pass over to your policy decision point. Here's this non-human identity trying to do this action, this resource. Your policy decision point will evaluate your policies, comes up with an authorization decision, creates an audit log of that decision, super important from a compliance perspective, and simply returns back to the application that allow and deny. Now you can run and deploy these policy decision points anywhere across your architecture. Cerbos is fully stateless, so completely horizontally scalable. You can run it as a sidecar, you can run it as a service, you can run it as a Lambda function type architecture, whatever really fits into your architecture. But really what this means is you now get the benefits of the richness of a full policy decision point and externalized authorization management solution. So you can start doing a centralized source of truth for what your policies are in your policy repository, GitHub repo, for example, have those fully tested, vetted, and audited for what those policies do. And then using Cerbos's role-based access control, attribute-based access control, and ultimately a policy-based access control approach for these non-human identities, you get that end-to-end security of knowing exactly what a identity has done, what exactly actions have been done inside of your system, along with the audit log, and then Cerbos, along with Cerbos Hub, gives you that insights and detailed trail of exactly what is going on inside of the system, and also allowing you to log down and rationalize about all the various magnitudes more non-human identities that are going to be working in your system today and into the future.